In this task, we're going to take a look at one of those principles that we've just been exploring to do with plate tectonics, and that is the age of the seafloor. And we're going to use GIS to help us to test out the theory and explore the world and collect some data. So what the theory tells us is that we move away from the center of the ridge, the mid-Atlantic ridge. The age of the seafloor increases. That's an important point. It gets older the further away you are from it. But you've also got this symmetrical pattern either side of the plate margin. And that symmetrical pattern in the age suggested that seafloor spreading was taking place. So we're going to explore that through the GIS map. You click on here to open it. And what you'll see is a GIS map with a layer on that's showing you the age of the seafloor. Now, of course, being a GIS, you can go and explore this yourself, but I've got some slides down here that will help you to navigate through. You're going to collect data from 3 locations. So we'll go to location number 1 here, which is just in the northern part of the Atlantic Ocean. And we're going to measure a transect here from Florida across to Mauritania here in Africa, and that's going to take us right through the middle of the mid-Atlantic ridge. So let's go and have a look at the instructions of what we've got to do. So there's slide 1, Florida to Mauritania, and then we've got to use this tool, Analyze Measure tool, to collect some of the data on the distance. That's this tool here. If you click on it, the Measure tool is automatically selected for you here. And if you come to the plate margin, remember we're ending up in Mauritania, we go from here. Click once, lift your finger off, and come over to Mauritania, and click again, and that gives you a distance there of around about, and we can round this up, around about 3,000 kilometers. So, what are we going to do with that? We then need to take 5 sampled points for each side of the margin. So we measure the total distance like we have just done, and we divide that by 5 to give us the distance between each sample point. So we have said that's 3,000. If you need to use a calculator, you can do it in here. 3,000. Just in case your number is slightly more awkward. Of course, you're ahead of me in that. It's 600. So you've got to measure every 600 kilometers. So here we go. At each sample point, you need to record the distance and the age, and you're going to put it into a spreadsheet. Here's how we do it. Take a new measurement here. So I'm going out from here, and I want to go approximately 600 kilometers out, and you just move that till you get approximately 600 kilometers, and that takes you to this location. Now, what is the age of the rock here? You can go up here to the layer and look at the key, but each of these thicker black lines represents an interval of 30 million years, and the thinner ones are 5 million years. So out to that thicker line, it's 30, 35, 40. Okay, so we can put that into our spreadsheet. So it's every 600 kilometers, and it's about 40 million years. Now, next one, double 600 kilometers is 1,200. So we keep going out here, 1,200 kilometers. Again, just as long as it's roughly there, and that's our location. So there's your thick lines, 30, 60, 65, 70, 75, 80, just a little bit more, maybe about 82 million years or so. 82 in there, and this is now 1,200. And you basically just go on doing that. I've added some more of these values in here, and I've completed that before. Just one little hack that gets you to autofill this to see if your numbers aren't quite as rounded as that. They're a little bit more complicated here. The spreadsheet is very clever. Once you've got 2 numbers in, it spots the pattern, just drag that down and it'll auto-complete it for you. So once you've got 2 in, then that gets you those, and then you go through and you measure all of those. So that's your data collection process. Once you've done that, the next stage is data presentation. You select this part of the spreadsheet from there to there, and we're going to go to Insert. We're going to come over here to Charts, and we're going to choose Scatter, and we'll just select the most simple scatter chart there. Now, at the moment the graph isn't presented exactly the way we want it to, because it has brought in as a set of data points this distance here, and we don't want that. So it's very simple to fix. You just go into Chart Filters, you come down here to Select Data, We don't want it to represent distance, so we're going to uncheck that, and we're going to click OK. And what you have there now is the age in the western side and the eastern side. Now you'll need to add your title in there, and you'll need to add your axes titles. You do that by clicking on the plus, and you can add in whatever you want there to complete that. But that is your graph, and what you're able to see is some of the trends that emerge in that graph, and we'll explore those trends in class. So that's one that you do for the first location. Back here, we're going to go a little bit further south, just zoom out a little bit to see where we are, from Brazil to Namibia, from there. And then we're going to go into the Indian Ocean because there's a constructive plate margin there as well. And we're going to go from Madagascar, the island, cross the plate margin to India there. I'll just get that out of the way so you can see. You're going to go across there and you're going to do the same. And you're going to complete the spreadsheet. You're going to draw those graphs. So you'll end up with 3 graphs from 3 data location points that help you to explore that basic principle that age of seafloor increases and that pattern is reasonably symmetrical either side of the margin.